Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking silicon at T is equal to 300 degree Kelvin contains acceptor atoms at a concentration of Na is equal to 5 times 10 to the power of 15 per centimeter cube. Donor atoms are added forming an n-type compensated semiconductor such that the Fermi level is 0.215 electron volts below the conduction band edge. What concentration of donors are added? Okay, here the question is asking us to find out the concentration of donors are added. Now let's look at the given informations. Initially they are saying contains acceptor atoms at a concentration of Na is equal to 5 times 10 to the power of 15. So we have Na value that is 5 times 10 to the power of 15 per centimeter cube. And donors atoms are added forming. So we are adding electrons. Donors atom mean we are adding electrons forming an n-type compensated semiconductor. So we have to know that this is holes, right? So this is holes. So when we add donors, if it initially it was a p-type semiconductor because we have holes. So if we want to make this one n-type semiconductor, we have to have electrons that should be above than holes value. We have to have equal number of electron and we have to have above in order to make this one n-type. Initially it's p-type, so we have to have above. Okay, that's what we have to know. And also they have given this Fermi level is 0.215 below the conduction band edge. It means EC, conduction band, minus EF, that's equal to 0.215. Okay, now we have to find an equation that is related to this one, and also that will give us the number of the concentration of donors. Okay, to find, if you look at the equations, there are a list of equations. That is the most suitable equation is going to be this one, KT ln NC over ND, right? But here we have to remember one thing, is the equation is given as ND, but in order to become n-type semiconductor, this one has to this initially we have holes, this number of holes, so the electron has to be above in these holes. So whatever the above value, that's going to be the donors value, right? So we have to subtract Na from this ND in order to calculate the real ND after we the above value. Okay, that's what we want. Now let's look at the equation. This is electron volts. Okay, so this is what we have right now, and the KT values, so you have to multiply Boltzmann constant with temperature. If you multiply that one, you will get 0.0259 ln of NC for silicon value. You have to look at the silicon NC for silicon value at 300 degree Kelvin. That is equivalent to 2.8 times 10 to the power of 19. This will be given in the question usually. Okay, and NT minus Na in the denominator. Now let's go ahead and rearrange this equation. So this is going to be what, 0.275 divided by 0.259 is going to be equivalent to ln of 2.8 times 10 to the power of 19 divided by ND minus Na. Now we have to get rid of this ln, so we can take e power both sides. If I take e power, this is going to be e power 8.3. If you divide each other, you will get 8.3, e power 8.3, and e and ln cancels each other. Here we will get 2.8 times 10 to the power of 19 divided by ND minus Na. Now let's go ahead and continue this one right here. E power 8.3, that's equal to 4023.8. okay, that's equivalent to 2.8 times 10 to the power of 19 divided by ND minus Na. So ND minus Na is going to be 2.8 times 10 to the power of 19 divided by 4023.8. If you divide this one, you're going to get 6.96 times 10 to the power of 15 per centimeter cube. Therefore ND is going to be this one plus Na. We already know Na value, that's given in the question, 5 times 10 to the power of 15 plus 6.96 times 10 to the power of 15. Since we have the same power, we can add them together directly. So this is going to be what we are going to have, 11.96 times 10 to the power of 15 per centimeter cube. So this is going to be the donors, the numbers of donors added. Okay, so this value is actually above whatever the value we have now. Okay, this is actually addition with the initial value. Like initially we have 5 times 10 to the power of 15, and this is the whole value above and the initial value also, because 5 times 10 to the power of 15 initially we have this one right now, and electron has to be this one plus above. So above is this one, 6.96 times 10 to the power of 15. So if you add them with this one, the total number of donors are here, right? So ND is going to be what? If we simplify this one, this is going to be 1.2 times 10 to the power of 16 atoms per centimeter cube, and that's going to be the total donors. Okay, and that's how we do this kind of problems. I hope this helps. Thanks for watching.